Anyway, thanks so much, everyone, for having me. I'm really thrilled to be with you. I have been to Malaysia, I've been to Malacca. Luckily, through Sunaik Chu, I've gotten ingrained in the culture a little bit more too, especially the startup community. And I hope to visit again as well. We hosted Sunaik in San Diego in late 2019. He spent a month with us, and we got to share notes on startups, which was great. And so still here, almost 2 years later, we are engaging and sharing notes together. So thrilled to be a part of this with you guys. As Futri mentioned, my background's a little bit of varied. I started in aerospace working on the Space Shuttle program, and we're going to talk in depth about that. And I I spent 5 years on that program, actually. And the retirement of the program actually is what pushed me into my startup journey. And so I was working on something. I was actually getting my MBA by night as well. And I don't know if I would have had the push to jump off a cliff and go all in on my startup if it wasn't for the impetus of the US space program coming to a halt, where 60% of our workforce was let go. We're talking 10 to 15,000 people were let go. I wasn't. I had kind of survivor's guilt because I was young and my job was spared. But we had 40 and 50-year-olds who were let go, and I felt that I needed to help them figure out their next path on their career. And that's what ultimately became Portfolio. So we're going to talk a little about that specifically around that time period for me, what it was like to rip the Band-Aid off and go all in on my company. We're also going to talk about the things that I did to test out my startup before I went all in. You know, there were a number of ways to validate the idea, to see, is this viable, and is there a market for this, before I had no income and was, struggling to find sales. So we're gonna talk about both the time period, what that's like mentality-wise for an entrepreneur to think about, am I ready? And we're also going to talk about relations of aerospace and in general engineering, how that relates to startups. And I'll give you a hint. It's a lot about wiring, sensors, putting sensors in the right spot to create ways of measuring things that you do. So that's what we're going to talk about a little bit. We're going to talk about how to measure any way possible to see if the things that you do have meaning, have traction. And I love to use the rocket engine analysis for that. But first, let me just do a little show and tell of Neal, the rocket scientist. Let me know once. I think you can see my screen now.
Yes.
There we go.
Okay, yes.
So this was me in 2008, pretty new out of college, and lucky enough to work on the Space Shuttle program. So this is Space Shuttle. I think it's Atlantis. It's on the pad in Florida, Cape Canaveral, where we launched it from. I was lucky enough to work on the shuttle, and I'll tell you pieces that I worked on. I obviously did not go to space, so I am not an astronaut. But I certainly got close to the shuttle and worked on hardware that eventually did go up to space. This was a fun. This is me and my two coworkers. We were standing actually in front of our hardware, the Space Shuttle main engine, and we were given astronaut suits because we were sent to space camp by NASA. So just for some size comparison, this is about 220 feet tall. And here's us down here. This is this is a giant fuel tank. So there's hydrogen here and oxygen. This is what was the fuel for our engines. These were separate rockets. These would turn on for 2 minutes and then get ejected, while the rest of the space shuttle would go on for another 8 minutes. And we'll talk a little more in depth around that. Has anyone, I'll stop in the chat real quick. Has anyone seen the Space Shuttle launch, whether in person or a video? Because I can show some close-ups of that too. In the meantime, this is, oh, go ahead.
It's better if you can show us. I'm really excited to see.
In a video is possible.
I will find some videos. We'll talk through it. We got some time.
Thank you.
Yeah, this is the back of the space shuttle. Let me find actually a photo. Let's see. Here. So here's the whole space shuttle. This is the engine that I worked on back here. There's 3 of them here. They're 14 feet long, so they go from all the way back into here. And that photo I think that I was showing was looking at the back. So the engines would come out of here, the 3 of them. This is the front of the orbiter. This is as they're taking it apart and retiring the space shuttle. They're getting it ready for the museums. So this was already, the shuttle was done being worked on at this point. And we got to get real close to it because of that. This was before the last launch. So we were there. We got to, a group of us were sent to kind of commemorate the last launch of it. Oh, and we'll come back to that later. Okay, so this is what an engine looks like when we test it. So that engine I mentioned that we work on, this is, it's sitting vertically, and we would run it through a full like hot fire test. So one at a time. When an engine first was finished being manufactured, it was actually my job to get it from the manufacturing line all the way to our test facility. So I had to actually physically get it moved logistically from California to Mississippi. This is in Mississippi where we would test it. We would pretty much try to recreate as many situations that it could experience on its way up to space as possible. So we could move it, we could change temperatures, stuff like that. And so I was in charge of testing it. So I would be there to manage the test program for a brand new engine. There's about 1 million parts, literally 1 million different pieces of hardware on one of these engines. So very complicated. They call it the Ferrari of rocket engines because this is reusable. So it's not a one-time test, one-time use. When the orbiter comes back from space, we have to get it ready to go back into space. And so sometimes that means retesting it. Sometimes that means certain pieces of hardware, like up here, we have to take off and inspect. And so my job was really, they called me an engine mother because I had to own a certain amount of engines. Like I had 6 engines that I knew very well. I knew engine 2061, 2062, like these were engines that were assigned to me. So I had to test them, I had to get them ready for launch, which I'll show you some launch videos in a second. I then also had to present a data package to NASA that said the engine is in good shape. You can now buy it. And they literally would cut a check in a sense and say, okay, we have a good engine here. Here is $60 million for this engine. And then I had to be there on launch day to make sure that the engines were working. And that was about 10 hours that I was there on launch day, actually sitting on console. I mentioned my other colleagues. Where are we? These guys. So we were a team of 3. We each had 6 engines under our purview. And so we would switch launches. So one launch would be me, the next one would be James, next one would be Brandon. And then we'd rotate through. So every three launches was my launch. And so that means I launched for the 3.5 years I was part of that program. I was part of 12 launches specifically. And with that time, we took 84 people to space. Pretty amazing job for a 23-year-old, I will say. Pretty lucky, that's for sure. So this is what a test facility looks like. So we are actually a same kind of thing that I mentioned here. This is kind of looking on the inside, and this is the engines actually sitting down inside here, and we actually test it. We have a vacuum actually kind of attached here that tries to recreate the vacuum of space, because at some point we get from 0 atmosphere to 0 atmosphere. And so we recreate as much of the orbiter as possible. So we've got vertical fuel tanks and oxygen tank, and the engine's sitting in here. I am very far away from here. I'm probably 2 miles away watching this through a periscope actually, or through a number of screens that tell me that the engine's doing well. The Space Shuttle main engine in general is very complex. So here's kind of a rough schematic of it. What we do is we take hydrogen, which is literally cooled down to -420 degrees Fahrenheit, and oxygen, negative 240 degrees Fahrenheit. We take these two, we actually burn them up, both on their respective sides, to spin pumps. And it's a turbo pump. If any of you are familiar with turbo pumps, we kind of burn fuel and oxygen to spin pumps to pressurize more of the fuel and oxygen, and then we burn them all over again through this fuel chamber. So we actually kind of have 3 rocket engines in each engine, which makes this really complex. We have to, obviously we've got really cold temperatures, negative 420 degrees, and it stays negative 420 degrees anywhere that it's red. So anywhere here, negative 420, and then inside in the yellow, this is upwards of 3,000 to 5,000 degrees temperature. So think about, it's hard for you to tell, but this is millimeters thickness of metal that keep 5,000 degrees temperature away from negative 420 degrees here. Pretty incredible. Designed in the 60s and 70s by some brilliant engineers. They literally had to design brand new metals just for to work on this. So literally created new alloy materials just for this engine to work. And I was lucky enough to work on it 30 years after it was designed. And obviously there was still a lot of work to be done there. So I'm going to take you through a little bit around this about my job. I had 450 sensors that were attached all over this engine. And I had to know intimately every sensor what it did, whether it was the speed that this pump was spinning at, whether it was the temperature inside the combustion chamber, whether it was the pressure inside this pipe, or you know, speed, other speeds here, other pressures, stuff like that. So a lot of sensors that I had to know intimately well, not only like what should it be, what's the right number it should be showing me, but what does a wrong number actually mean? So if it's wrong, is it the sensor that's wrong, or is something bad happening to the engine? And I had to learn characteristics of the engine to tell me when is it a sensor that's gone bad, or when is the engine going bad itself and it's going to blow up. Many times the sensor has gone bad, and you know you're okay. But to get there, we had to practice and learn, and I had to study thousands of hours of previous tests and launches to get to know that. But first thing, I had to know how to, in a sense, wire up an engine. I had to understand, why would I measure something here versus here versus here? What would that tell me about the engine itself too? And so in learning about how to wire and how to measure, I really understood how to run scientific experiments, because I got to say, well, why wouldn't we test something here? Or why wouldn't I test something here? And so I learned a lot about science, learned a lot about the scientific method of running, having a hypothesis and saying, here's what we think we can learn if we do something different. And that, I'm going to tell you, pretty much is a lot about running a startup. It's having a hypothesis that says, I think I have an idea, and I'd like to test the idea to see if it's a business. And here's how I plan to do that. And here's how I plan to replicate it. And here's how I plan to scale it. And so all those areas we'll talk about a little bit more in detail about how rocket science and aerospace relates to startups. But I think you want to see more space stuff for now. So let me show you 2 fun videos. I'm going to show you first just a space shuttle launch, and then I will show you what our engine specifically look like. All right, I'm going a little bit on a whim here. I hope it's a good one. We're going to forward ahead here to the good parts. So first of all, let me pause this. So on a day like this, a launch, I would have been there 10 hours before launch. We have a 10-hour clock countdown, and it's because we actually have to fuel the engine, and it takes 6 hours to fuel it up. And because we have such extreme temperatures of negative 400 degrees, the metal bends, it shrinks, it expands in some places. And we have to watch and make sure that the space shuttle does all of the right bends that we expect it to. And we have to also make sure the sensors are okay. Oftentimes it's so cold that we break sensors, and that was pretty typical. So we had to sit there and be pretty much on call on station, and make sure that everything's good. And actually, I'll show you a picture of what mission control looks like.
Sorry, Neil.
Yeah.
I'm just curious if, let's say, during the 10 hours of buffer and you spotted few sensors that's malfunctioning. So how do you fix it? Do you really fix it, or you just leave it as it is?
It depends. We have triple redundancy on pretty much everything. And sometimes what we will determine is it's a sensor issue, and either it's a known issue. So I would have to actually quickly pull up data and say, oh, we've seen this sensor go bad 10 times. It's a known issue, and we've flown with it 10 times, no issue. And we'd have to clear it off, write paperwork, and say we're good to go. And a few of the people have to give the thumbs up on that. If it's so pretty much we first dive into the data and say, have we seen this before? If we haven't, we may have to send out a crew of people to go and test something on the launch pad. And hopefully we try to do this before the astronauts have been installed. We try to do as much as we can before there's humans there, just in case we have an issue. Also, because they get strapped in a really awkward position, we don't want them there for very long. So we want, once the astronauts are strapped in, we really want no issues at that point, because they're upside down, they're very uncomfortable. We'd really love to just get them to space really quickly. So yeah, that's typically kind of what we're going through. Here's kind of a typical scenario. I was in one of these, mission control. We also had built a version of this in California. And so even when it wasn't one of my launches, I was still there at our own home base version, supporting my team member who was here. So that team of 3, we pretty much were there for every launch. It's just, were we in Florida or were we in California being a support team member? You can see a ton of screens, a ton of data. It's hard to tell, but this screen looks like it's got hundreds of lines of data streams, and that's pretty typical what we'd be looking for. So 10 hours, we're on stat, we're waiting there. And the whole ride, the space is only 8 minutes. So it's a really long time to wait around for kind of a boring 8 minutes in a sense, because if really you can't, once it's launching, you can't do much. It's going or it's blowing up. And it only blew up twice, or actually only blew up once on liftoff. So 1 out of 136 launches went bad. Obviously, we lost life. It was terrible. There's zero anything to be proud of there, but we're proud of at least that had very little issues on the way up to space for sure. All right, let's watch a launch real quick. Let me see where that video went. Here it is. It's going to go kind of quick, so I'll probably explain things after the fact.
System activated. E-10.
All right, so we're at 10 seconds left here. These sparklers go off to, if there's any extra hydrogen that's been floating around as gas, we try to explode it so that when these kick on, you don't have a giant explosion or plume. So these are my engines here. I think we've already tested practicing maneuvering them. They do kind of a dry movement of throttle, or not throttle, of gyrations, because this is how you steer the orbiter, is by moving these engines, in certain directions. All right, let's watch this, and then I will come back and share more, or maybe I'll see something and I'll pause it. We'll see.
9, 8, 7, 6, 5, 3.
Okay, so at 6 seconds, you saw the engines ignite, and actually one lights, then the next lights, then the next lights, and within a second and a half, these engines are on, and the computer determines we have a good engine. We're good to go, literally within a second and a half. These mock diamonds, you'll see there's 3 of these diamonds. They actually start inside the bell of the nozzle, and they quickly push out once the rocket engine settles. And I'm going to show you a version of just one engine launching, or starting up, and you'll see how much happens within that 1.5 seconds. It's pretty crazy.
2, 1, 0, and liftoff of Space Shuttle and Atlantis on the mission to build, resupply, and to do research on the International Space Station.
Houston now controlling. Atlantis begins its penultimate journey to.
So right here, you can see it's rolling, and that's due to our engines controlling and rolling down. It's just because of the, specifically, it's the best aerodynamics for the engine to do that. So you can see our mock diamonds coming out the back of our engines here. To give you a sense of power, these are about 2.5 million pounds of thrust coming out, each of these. So you get about 5 million pounds of thrust between these two the solid rocket boosters. Each of these are about 500,000, 500,000 pounds. So together we're 1.5 million here. Actually, maybe that's wrong. I think these are each 5 million pounds of thrust, and this combined is 1.5 million. So something like that. Wow, I'm a little rusty on my thrust pounds. Anyway, these are much bigger engines, but they only go for 2 minutes, and ours go for 8.5 minutes. And these are using fuel built into the white part themselves. Then they get ejected and thrown into the ocean, while the orange piece is what's fueling our engines down here, which feel really tiny. They're 14 feet long, remember.
Shore off the International Space Station. Atlantis now in the proper alignment for its 8.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Outpost. 30 seconds into the flight.
So we're only 30 seconds in, and it's already a few miles up. It's gone pretty quick, but it actually hasn't reached what we call max Q. And so at some point, you break the sound barrier, and that could be actually detrimental to the space shuttle. And so we actually slow down on our way up and kind of ease in to breaking the sound barrier. So that's something that I think is about to happen here in 1 second here. And by the way, STS-129 was a launch that I worked. So this was one that I would have been at the controls, not at controls like doing anything, just watching data. But this was one of my launches.
Atlantis almost 2 miles in altitude, almost 6 miles downrange from the Kennedy Space Center already, traveling 500 miles an hour.
So 500 miles an hour. We break the sound barrier between 700 and 800 miles an hour. So you're going to see something like kind of a mock diamond come around the whole orbiter, I think, pretty soon. You can see these are the attachment points where the orbiter attaches to that giant orange tank. And I think we'll keep going.
The 3 liquid fuel main engines now throttling back to 72% of rated performance, going into the bucket, reducing the stress on the shuttle as it breaks through the sound barrier. 55 seconds into the flight, all systems operating normally, 900 miles an hour. The speed of Atlantis right now, 6 miles in altitude, 9 miles downrange.
Atlantis, go with throttle up. Copy, go with throttle up.
So that call means we already broke the sound barrier. We can now go back to full speed. And you can see our engines here. It's kind of a night launch, so maybe we wouldn't have seen the breaking the sound barrier part, but all good. But you can kind of see how I mean. Like I'm sitting here I would be sitting here watching a computer, and it's kind of boring in a sense. Like if everything's going well, I don't have to do anything. It's great. And even if something was happening, I couldn't. The computer is designed to take over for me, like for us. There's no way that we could react fast enough and make a decision compared to a computer. So for the 8 minutes of this going to space, that's actually the boring part.
Throttle up call acknowledged by Commander Charlie Hobaugh, joined on the flight deck by pilot Butch Wilmore, flight engineer Randy Bresnik, and Leland Melvin. Seated down on the middeck are Mike Foreman and Bobby Satcher, kicking off their work week with a Monday commute to orbit. 1 minute, 30 seconds into the flight, Atlantis 13 miles in altitude, 15 miles downrange, traveling almost 2,000 miles an hour.
So I'm going to skip ahead real quick to when they eject the solid rocket boosters. There they go. Those are ejected once they burn out.
Booster officer confirms staging a good solid rocket booster separation. Guidance now converging. Atlantis steering into the center lane of Highway 129 en route to the International Space Station. 2 minutes, 20 seconds into the flight, 34 miles in altitude, 48 miles downrange. Atlantis traveling 3,200 miles an hour.
So eventually we get up to over 17,000 miles an hour is pretty much in orbit. but we eventually get up to about 25,000 miles an hour to catch up to the space station. So I'm going to catch us up to the point when we eject and the engines are done. So at this point, our engines are turning off. They're going to call that the engine's clear, they're off, and then they're going to eject. There we go. This gets thrown back into space. Our engines stay on the back here.
External tank separation.
So this,
Atlantis now in its preliminary orbit.
So this tank actually burns up as it comes back to the atmosphere. Unfortunately, I think it would be great if we could reuse it for how much engineering work goes into it, but you know, that's how they designed it. Our engines stay on the back here, and actually they do nothing for 14 days. I kind of sit and have to wait for my hardware to come back from space, and my job's done at this point. There's no fuel, the engines are off, and we're super thrilled that the astronauts got to space successfully.
Commander Charlie Hobaugh will now maneuver Atlantis.
All right, so that's, any questions around that? I'm happy to take some while I queue up one more video real quick.
We have a, if there's a question, we have a comment here. Theo was saying, me and my lecturers, Mr. Willie, stay late night till 4 to 5 a.m. Watch SpaceX Falcon 9 launch live together.
Let's do it. Or is that? Oh, really cool. All right, let's get back here. Okay, I think this is going to be a slow motion version of the engines turning on. What I love to show you is that these actually start wobbling. And think of these are massive, 14 feet long, solid metal, able to withstand 5,000 degrees and 420 degrees negative on the outside. And yet they wobble. Let me make. Hopefully this version has that. And why it's doing that is because the initial explosion that comes out is so strong, and it's unstable. It takes about a second for the right fuel and air mixture ratio, or fuel and oxygen mixture ratio, to come together and find the right mixture ratio, and then find sustainability. So I think you'll see one turn. This is when you'll actually see 3 different starts to these engines. Let's see, here they come. The starts are about to happen. You already see fire coming out of one. So it's not consistent yet. So this is the first second. Then here's the second one starting, and then the third. And so obviously this is pretty slow motion. Can't tell, but this all happens within pretty much 1 to 2 seconds total. Still, these are not consistent fire yet. You know, they're kind of inconsistent. You don't have that solid white, bluish white plume that you saw before. So the engine is still, in a sense, starting up. Kind of like your ignition, which also takes about a second or less, of your car. This is about the same. So now you can see starting to have these, let me actually go back a second. You'll see these lightning bolt kind of things, and this is when the engine is, actually it's a good thing. It means that it's getting past the speed of sound, and it's pushing down out of the nozzle. And now we have 3 good engines. They're ready to go, and that all took about 1.5 seconds to 2 seconds. Once that's good, then automatically the white boosters, which are you can see here, they'll light up on their side. Let's see if we see actually that start to take off. Oh yeah, we'll see it soon. The difference between our engines, you can actually turn these off, where these white ones, once they're on, you cannot. So that's why we test ours first. They come on first. We make sure we've got a good engine, and then it's go time. Then the big boys turn on.
We have a question from Johan here. So what happened to the rocket booster after the launch? Is it collected for another use, or did it just turn into trash?
The white ones are collected. They're picked up by a ship, and they are reused. So they actually fall into the water. They're not as smart as SpaceX's, which land on a pad. So you can see here, yes, it's finally taken off. So all that 3 minutes worth, that all happens usually in about 8 seconds. Let me find one more video. Sorry, there's a really good one that just shows our nozzle wobbling. No. Let's see. All right. If not, that's okay. I thought there'd be one specifically of just like one of our nozzles wobbling. All right. So that's how the space shuttle works. That's how our engine works. And like I mentioned, this was kind of what I lived by. I understood where all the sensors went here. Because I had to understand when something came in here, what did that do downstream? And that's a lot like a startup. What inputs do you have and what outputs can you actually measure that those inputs do?
Yeah.
Let me take you through a little bit about...
We also have another question from Aslam here. How do you avoid colliding with junk in space, like debris and other particles?
That's a great question. It is a bigger and bigger problem. And honestly, sometimes you can't. So there is impacts to the space station that happen all the time, unfortunately, that it gets impacts. Most of them are small enough that they don't cause damage, but there's been many impacts that affect the solar panels on the space station, which are these giant wings, right, that kind of come out. But there is a United States Air Force whole department that is in charge of tracking every little piece of space debris, and they track it and they know exactly where it is and they predict impacts. Satellites often have to be moved up and down because they can tell an impact could happen. It's a huge problem. Space debris is a massive problem and could, you put a $2 billion satellite or the space station, $100 billion to build that thing, and one piece of space debris could take that down. And the problem really is that other spacefaring nations, like a China or a Russia, don't take it as seriously, and so are okay with debris not burning up and staying in orbit, unfortunately. So I perceive that an actual space business that is coming up is cleaning up space. I actually think that we will see a lot of startup opportunities to try and clean up the debris in space.
We also have another question here. What do you think is the reason humans are willing to take the risk, time, and resources to go into space? That's very
deep question, big one. A few reasons. One, I think naturally humans are always curious about what's over that next hill, right? Why did we chart out Antarctica and the Arctic and find ways to bridge from Asia to North America? We're just curious. We're explorers, and so there's one piece of that, right? We're always curious what's out there. Also, the challenge: can we do this? Right? I think engineering wise, we love a good challenge to say, can we do something that hasn't been done before? Elon Musk's his thing is that he thinks we as humans, our next challenge is to be able to be multi-planet race, meaning be able to show that we can, one, live, I guess, happily on Earth, but also and be able to take that to another planet to shows an advancement as a race. That's what he thinks, and I think so as well. I think we still have a lot to learn how to run the show here on Earth before we go try to bring the craziness to another planet. But we might as well start trying to see if we can at least bring something to another planet. So yeah, I think the natural explorers and all of us kind of drive us towards that. Good question.
Okay, go back to the technical question. So how is it to determine the number of booster engine used for the space shuttle? Why it is 3, not 2, 4 booster or 4 booster?
Yeah, so that was all in the design phase. Actually, it's really tough to get up to space. And actually, what's hard about it is down on Earth, it's actually the air that really slows you down. And so the heavier objects that you need to bring to space, the harder it is to get it off the planet. Now, once you're already up a few miles into the air, it's actually easier because you have less air that you're trying to push through. Air does a few things. Air causes friction on the body of the space shuttle, which causes heat, which can do a lot of things to slow you down. And so you have to design a few things to, one, get yourself past the air point. So that's why we have the solid rocket boosters to really get us up to about 30,000. What are we at? 30, I think it gets us up to about 10 miles where the atmosphere is much thinner. And that's why they fall off. They're so heavy also that we don't need as much. Once we've gotten up to 10 miles up, those fall off, and now we don't need as much thrusts to get up because we don't have the air that we need to punch through. So you kind of have a design weight challenge there. How much boosters do you need to just get you up to that plate? And then do you keep those boosters all the way up, or do you drop some off and maintain? So it's a big balance of figuring out the right thrust at the right altitude. I don't have the right answer of why 3 versus 2. It's just that that's what was designed in the late 60s. That was the right ratio of 3 boosters, 3 main engines, 2 boosters, because it was designed to be kind of a pickup truck. That's actually more what the space shuttle is. It's in this photo, where is it? It's got this, let me zoom out. So this is a 60-foot bay here. This can carry something that's 60 feet long. So obviously this was designed to carry heavy objects like the Hubble telescope, like other satellites and pieces of the space station. And so when this was designed to say, hey, we need to bring heavy objects to space, that's kind of when we decided, all right, this is the right ratio of some main engines that have heavy thrust and giant boosters alongside it, based on kind of what the mission is. You will see now, like SpaceX's launch and others, they're little capsules. Really, all they're bringing up to space is this part. You know, they don't need this whole body, and so they don't need as much thrust because they're just bringing 4 people to space. This thing brings 7 people to space plus 60-foot long objects, massive. So that's why we call it the pickup truck. So it's totally dependent on the mission of each space, each space station, or sorry, each orbiter, whatever it's designed for. That's kind of what you have to design the propulsion for. And this arm, maybe some of you have seen, this is a giant arm that can lift things out, can move things, and connect to other things. So it actually was used to kind of pull the shuttle into the space station. This is where the connection point would happen, and this is where you'd flow back and forth between the space shuttle and the space station itself. And actually, have any of you seen the space station in the sky? There's actually some fun websites where you can see where is it right now, and you can try to look for it. And on a pretty, if you're in a dark enough spot, you should be able to see it moving across the sky. So just look up like ISS tracker, and you should be able to spot the station. You should be able to put it into a map, like where are you, and it should be able to tell you where it is, and you should be able to see it. So it looks like a fast-moving satellite across the sky.
Oh, wow. Okay. All right. That's interesting. Any more questions?
Yeah.
So far, very good. You can continue.
Okay. All right. So let me take you through a little bit of some of the other startups that I have worked on, so I can talk you through, some of this knowledge that I picked up and where I applied it to. Also, let me just check. Is it really dark for me? Oh, no, it's good. All right. It's getting, we're just after sunset here in San Diego.
You're good. You're good. You can still see you.
Okay. So, like I mentioned, I was starting to, so at the end of the space shuttle program, I luckily stayed on, but I was starting to tool around with some other ideas that I had, whether it was how to help my fellow colleagues who had just been let go find new careers. But I also had and my eventual co-founder of Portfolium, who's not in this photo, I don't think, no. We played around we'd been friends for 5 years. We started on the same first day together, working on the space shuttle. We spent pretty much most of our lunches together. because we became fast friends. And we found that we both had a knack for coming up with ideas for either business ideas or exploration of some sort. And so one of the things that we did, we built what they call a weather balloon, and we tried to launch it into space. So we actually filled a balloon with helium. This balloon started at about, what did it start at? It started at, I think, at 6 feet in diameter and grew to eventually to 10 feet in diameter. So it was a really large balloon, obviously. Our whole goal was to get it into space, or as high up as we could, get pictures of what space looked like, and then recover it. So there was kind of like this online challenge happening. This was around 2011, 2012. People were saying, how could you get a balloon and picture of the planet for as cheap as possible? And so the record was $220, I think, was the cheapest someone had got it. And part of those were like the materials. The helium itself was expensive. And so we said, all right, game on, we're going to try this. So we designed a little package that held a camera that we built. We wrote our own little code that auto took a picture every 5 seconds. So as soon as we let go, it was taking photos. We also had to wrap it in material that kept it warm, because it obviously got pretty cold as it went up to space. So we built little heating pads around this. And then we took an old flip phone, and we programmed it to take its GPS coordinates and text us every 5 seconds also. And so that way, when it came back down, it would start telling us where it was. We thought, and so anyway, we built that, we launched it, we had a few fails, we had to put more helium in it. It eventually went up, and we didn't hear from it for 3 hours. And what happens is, once you get to a certain altitude, you don't have cell service anymore. So we lost track of, we didn't get text anymore. But we knew at some point, most likely the balloon would pop and it would come back down. And so we actually had designed a parachute into this package too, so that the parachute would hopefully slow it down. And so we recovered it 3 hours later. We had made a calculation that we thought it would take, it would go 30 miles away. It actually went 60 miles away. So when it started texting us, we were really far from where it was. We were 30 miles away from where we thought it would land. So it took us a while. But lo and behold, it was in the desert. We caught it. It's really hard to see here, I know. I'll try to zoom in there. That's me holding the balloon exploded. But look at these photos that it took. This is a photo from this camera. It's like a little Canon. It went up about 103,000 feet into the air. So theoretically, it didn't go into space. Space, by NASA's determination, is 60 miles up. We were nowhere close to that. We went about 3 miles up. Or no, more than that. That's bad math. What is it? We went about 20 miles up, I guess. No, why am I doing that wrong? 100,000 feet divided by 5,000. Yeah, so nowhere close to space. But still, look at these photos. Like, we actually got to see the curvature of Earth. Pretty cool. So this was over Los Angeles. This is the Pacific Ocean. Anyway, so that was my first project that I played around with my eventual co-founder. We kind of learned what we both were good at. He was good at programming this. He programmed both the camera to take the photos and for the GPS to text us. I was good at some of the other materials and kind of figuring out and finding the cheap materials that we could find and just being resourceful per se. And so we got to present this at our company as a fun project that we did, and everyone was like really into it. So that was my first project where I got to learn, me and my co-founder, on a non-business company, in a sense. This wasn't a startup, but this was a project where we got to learn about each other and how we work together. And I'd say that was pretty important for us to see, first of all, we like to do different tasks. So that was important, right? If we both want to do the exact same thing and we didn't want to do the other stuff, that would have been really tough. But every project usually takes a lot of tasks. And so the fact that we were able to divvy up some of them and divide and conquer really helped us a lot. And so, you know, from there, we worked on a few other projects together. And eventually we had been playing around with this idea where you take kind of visual nature of things you're proud of, and you build it into a visual resume. And that's what eventually became Portfolium, which is called now kind of the Folio Network, meaning it's designed, let me find a good version of it. It's designed to kind of almost like be a really good UI version of Dropbox meets LinkedIn, meaning you can ingest any kind of file, whether it's sound or videos or pictures or even 3D models, and you can organize it in a way that says, here's what I'm good at. Here's why I'm good for this job. And that's what we designed Portfolium to be. Now, I will say we had a lot of pivots. We originally wanted to be LinkedIn for college students. So we thought we were building not just a website for you to put your stuff, but a whole network where you would connect and meet other people. You would, you know, find other people who had similar skill sets, and then employers would come and recruit off this platform. I will say, one, we never really got employers to use the platform at all. Employers would not pay for the platform to access the talent that we had on there for a few reasons, and I'll get into that in a second. But first, as I'm getting into this, any questions before I dive too deep into Portfolium?
Any questions? So far, there's none on the, oh yeah. How did you launch the balloon?
So the balloon was launched, we filled up with helium. So you can see there's a tank of helium here, and we tied it really tight, a whole bunch of zip ties, and then we let it go. And so that's it. That's it, me letting it go. And the helium naturally pulled it up. The balloon expands as air lessens around it. So as the atmosphere shrinks, it actually expands on its own. And we knew that it eventually would overexpand and blow up. It would pop. And so that's how we knew it would come back down, was once it got to a specific altitude, it would pop. And that's why we had the parachute on it.
Okay, so far no more questions.
Wow, I look really young here. Okay, so back to Portfolium. So yeah, our premise was originally, like I mentioned, Portfolium's goal was to actually help the engineers who had just been let go from working on rockets, right? So how did we end up with being a place for students? Well, a lot of pivots. We had a lot of talks where we first had our ideas sketched out on paper saying, hey, you know, we know it's going to be really tough for you to find a new job because you were working in rockets, and in 2012, 2013, there's only so many places that were hiring rocket engineers, you know? Even today, there's only so many jobs that are hiring that. It's a very specific skill set. And so what we said was, how could we use your 30, 40 years of work experience? How could we use our platform to explain how your skill sets apply to other industries? That was our premise. And, you know, I think we struggled there. We made, it was really hard to find ways for, you know, a 40, 50-year-old engineer to say, yeah, I can show you pictures of my work. First of all, if they're working in aerospace, a lot of times the stuff's classified, or you can't take the exact photos, or even a photo doesn't do it justice. You need like a 3D model. And a lot of times they didn't even have that. They couldn't take it out from work. They couldn't show that to other people. So we struggled to find the visualizations to say, here's the work that I do, instead of writing out bullet points. And ultimately, a lot of them went to LinkedIn and said, you know what, LinkedIn's fine for me. And so we had to find who was the audience that really had a tough time using LinkedIn. Really, that was our premise, was who struggles to use LinkedIn. It was either people like maybe in blue collar work, you know, where no one else in your network is there, right? Or people who don't have work experience yet, right? People who have nothing to put on LinkedIn. And that's why we eventually pivoted to students, because students typically don't have years and years of work experience yet, right? I would imagine a lot of you can relate to this. Maybe some of you struggle to even use a LinkedIn properly because you feel like, oh, I haven't had a formal job yet, or I haven't at least had 3 jobs. Well, I don't want to have a blank profile. And that was our premise, was build a place where people could fill it out, whether it's sports that you're in, and how can we tease out of you to say, what did you learn out of being on a team that shows that you're good on teams, right? Like you're good at being the captain or something like that. So we really wanted to find a way to survey you and pull out information that showed relevant skill sets, and then display it in a really concise way that says, look, this person is good at blank. And so that was a lot of our pivots, was understanding that, was asking the questions, who's our ideal audience? Now, not saying our audience was, by the way, our customer, right? Because in the end, students really didn't pay for this. We actually gave it away for free to students, in the hopes that employers would be the ones who would pay to access the talent. So we kind of tried to at first build a bit of a Facebook model where it was only let certain schools on and make it feel like there's some FOMO, fear of missing out. Like, oh, my school's on, it's exclusive, got to use it. And so what I did was I was taking vacation days and sick days from my rocket job, and I was going to universities and talking to students saying, hey, where are you having problems in the job search? Try out our tool. We'd love to have some feedback from you. We also were talking to professors at the same time saying, would you be willing to try this in your classroom? And we were trying to find also maybe who at the university would be the one who would kind of be a channel partner, meaning who would be the one who would get all the students on, and we wouldn't have to get one student at a time. So we're kind of looking at already like scalability of user acquisition. Where could we do that at a university? It ultimately, so I took a lot of sick days, a lot of vacation days to come figure that out by spending time at my alma mater, the school I graduated from, UC San Diego. I was living in LA at the time, so I was driving down about 2 hours to come and just spend a day or two doing customer development work at my university. I definitely used the whole I'm an alum card big time. So I got meetings with, department heads and the chancellor of the whole school, trying to just get meetings for someone to kind of be my champion, say, oh, we really like what you're doing. Here's a green light to go test it with blank population. We weren't even asking them to pay for it. We just needed someone to kind of give us their blessing to say, hey, use our school as a sandbox. And so it took a lot of just being on campus, meeting people, and saying, who likes what we're doing and who will vouch for us. Once we really started, also at the same time, we're talking to employers. And so we would go to, say, a career fair, and we would go up to every employer there who had a table, and we would, instead of pitching them our resume, we'd pitch them our startup idea and say, what do you think of this idea? And they're like, well, we're here to hire people. We're like, yeah, but would you want to use our tool to hire people? They're like, I guess so, sure, but that's not what we're here for right now. And so it would kind of catch them off guard. It was what we were hoping to get was like a follow-up meeting. And really we were just collecting business cards so that we could go to employers afterwards and try to get their attention later. But it was hard to get their attention at the career fairs. And ultimately we found that really employers weren't paying a lot of money to be at those career fairs, maybe $1,000 total. And for $1,000, they could collect like 300, 400, 500 resumes. So it's actually pretty cheap user acquisition for an employer to get a bunch of resumes, and which is ultimately what we found out was really hard to get them to pay for Portfolium. And so we kind of abandoned that, the employer side, after we found that people don't pay for college talent. College students usually, you guys tell me, are hurting for jobs. Like you guys will do anything. You're clamoring to get the job when you graduate. It's not a feeding frenzy for employers. At least in the United States, it's like that. And so we found, you know what? We don't have a great market here to build a marketplace. What we have, though, is a tool that is really good at organizing your information. And so ultimately, we found that the university was our buyer. They were the ones who paid to get their entire student population on. And why? And it then took us a while to figure out who was the buyer at the university. We thought it'd be career services. Well, turns out career services, and I'm giving you some pretty inside knowledge of at least what we learned here. Career services, I'm going to be point blank here, doesn't care about you the second you walk off campus, at least at schools in the United States. They care about you while you're a student. And the second you're not a student, you know what? Their services in the States are rendered obsolete. And so that was.
I have to start you there, Junri, but is that true?
That might be true in US, but it's not in MMU.
Oh,
Just the United
to share with
States.
you, yeah, it's okay. Yeah, Neil, just to share with you, our president made strong statement on this, saying that once the student graduate, they are still our students, so we will have to provide after service for them even they graduate.
Good.
Yeah.
Great.
so they receive a mandate from the big boss.
Yeah.
It's super important that is the case, because we found it's a long-term approach to the student's journey, and a student's journey doesn't stop on graduation day. It's for life. And so for us, we found the alumni services were the buyer for us, because they are the ones who are going to make sure that they care about you for life, because they want you to donate back to school, and they want you to feel connected for the rest of your life, that the school gave you tools for life. And it took us a while to figure out that alumni where's our buyer. We talked to a lot of departments first and had that conversation that says, hey, yes, you may have budget and maybe you spend money, but do you spend money in a way that shows that is a tool for life for your student? Or do you only spend money in a way that helps the student get their first job, or just an internship, or maybe not even like a career, but maybe like a part-time job? And that's what the universities in the United States, we found that career services, they really just are focused on first job, whatever that is. And alumni, we're finding now, have started to actually take over career services and put it under their department, because they realize career means whole life. But we were just at the cusp of that kind of change of thought in 2011, 2012, and 2013. But ultimately, that was our buyer, alumni services. And it took us a good year to figure that out. I'm going to pause there to talk a little, see if there's any questions around customer development, around finding first customer and ideation. Anything there that anyone wants to ask around? It's starting to get a little dark here. Give me 1 second. I'm going to turn on some lights.
Okay, sure. Any questions, anyone?
Ooh, I've got a beam of light coming out of my head. Let me stop presenting for a second here. Can go back to full screen here. Any questions so far? Is this interesting? Hopefully.
Yeah, it's definitely because we get to learn that you probably think that portfolio is great, right? Because your main aim was you wanted to help those engineers, but then you realized along the way that, wait, hang on a minute, who's going to be our customer?
Yeah, exactly. We had this idea, but it wasn't validated yet, right?
Mm-hmm.
We had this premise that, hey, we think we're building something great. Everyone's going to love it. Well, just because you build it doesn't mean anyone will come. And so we also found a few things, and this is not to speak for any other students, but we found a lot of students at universities we were at don't really care about the career until a few months before graduation. We thought
that goes to me.
Our premise was that you care as soon as you step foot on campus, everything you do, you're going to want to document to show here's 4 years worth of learning to get the job. Well, no, most people are focused on just getting the grade, and it's hard to lift your head and say, how does this all turn into a job, right? How does everything that I learned today in class turn into a career tomorrow? So that was another part that was really tough, was to get students to early on in their college career to say, yes, I want to document my learnings. Really, it was just people, we had only a tight window, just the last 6 months of college. That was our customer, right? The ones who were like, oh no, I'm graduating soon, I got to have a job. So we had a tight window, a much tighter window than we thought. So what also helped was tricking people, in a sense, to auto-saving their work throughout their 4 years, so that when they started caring about the job, all their stuff was there. They didn't have to go searching through like random binders and hard drives. So that's what happened. That's what came in really well when we partnered with a company called Canvas. And maybe you guys have heard of Canvas. Do you guys use it right now?
Yep. I don't, but yeah, maybe some have already used it.
Canvas is a learning management system. It's probably how you teach your classes or sign up for classes, get your grades. It's kind of the modern operating system of universities. And so we partnered with Canvas. They had like an open API where we got to share data back and forth. And that's the company that eventually bought us. So I'll give you this spoiler down the road. They found that what was happening was that people were turning in homework and getting grades, and nothing would happen with that, right? You get it graded. Well, what if you could save it to, you know, a big Dropbox or something like that? That's what Portfolio was. So anytime you turned in something, you started to save work and you started to build up a portfolio of things you're proud of, right? You could say, oh, there's that A paper I got, or there's that project I did. There's that, you know, scientific experiments where I learned some things. That's what Portfolio started being, kind of started being this repository of work you're proud of. And so we, in a sense, tricked students into saving their body of work. And so when they were ready for the job, they had it all there ready for them. And so that worked out really well. And that's part of why Canvas, or their parent company Instructure, acquired us a few years later after the fact.
We have this question. Sorry, Dave.
Yeah,
we have a question. The certificate is important. Certificate is important in US.
Certificate is important. It definitely depends on the job. Certain jobs require that you're certified in certain things, and so yes, I would say yes. It absolutely is important, depending on if it's, you know, a job that requires that.
So Kia is asking, does it also save the bad assignments?
It does, and you can hide those. So it saves everything, and so then you can curate it and show off, here's the top 10 that I'm proud of, and you can delete if you really want to as well too.
Okay.
So let me talk a little bit about the data piece and why, you know, connecting back to the rocket science side. Actually, we got one more question here. Using Portfolio should keep tracking on what you've done throughout campus life from day one. Yeah, ultimately, you know, the more you save, the more you can look back and say, here's what I've learned. Here's how I've changed as a person. You know, people like a good story when you can say, I entered university thinking I was going to study marine biology. And over the course of a few years, I determined I'm a better linguistics major, or I really love engineering, or I like, you know, writing. People actually like to see what's unique about you and what's your story and what's your journey. So the more that you can save and show what's unique to you, we thought was really important. Also, there's gonna be a lot of people who have the same degree as you, right? Everyone with a business major, on paper, you theoretically look all the same. So we think if the more that you save things that show yourself as a unique individual and you have unique skill sets, the more that sets you apart for when you're applying for jobs as well too. So that was another big factor that went into saving as much as possible so that you could be as unique as possible too. So a few things that went into learning about our platform. We determined, you know, when a university paid for Portfolio, they're going to want to know a number of things. They're going to want to know, one, the total population that they onboarded, how many people actually utilized it, and they started asking us on a weekly and monthly basis, because they're paying for license in a sense, right? And so they want to know, is only one person using this, or is 10,000? And so for us, we had to start learning how to measure and building a dashboard for what we call key performance indicators, or KPIs. And we had to start discovering what are our KPIs that our customers want and are important. And we had to first learn how to measure them, and we had to take some of the bad news with that too. Sometimes our KPIs were low, and what could we was it a product issue? So maybe the product was in a way where it was hard to log in, and so people just weren't logging in. So do we have to work on the product itself, or was there actually like kind of like people didn't know how to use it, or didn't understand the power of it? It's kind of a sales and marketing effort that we didn't train people pieces too. So there's a lot that measuring data started to tell us about. Should we put effort into building more product, building more training, having customer success, or doing better sales and marketing up front? And all of those pieces came from data. And if we didn't learn how to measure the usage of our platform, we never would have known where to put investment on engineering team or sales and marketing or customer success. We could have thrown it all into product and said, we just want to build out great features. But if we didn't really know if anyone was using it, it would have been a big waste. And so just learning how to harness data and understanding how to read raw data, then step 2, how to tweak that. What knobs are at your disposal? What can you change? If I sent out an email to every one of our users and said, hey, we noticed no one uses this feature, here's how you do it. Could that change our product, right? Or if we gave someone a little feature that said, here's how to share your portfolio, would that get a lot more usage? So we start to learn, once we learned what our data was, we then start to learn what could we do to turn some knobs and tweak it, make things go up, go down, good, bad. And that's super important, that you just learn how to just see what you have control of and what you don't have control of. And we can dive much deeper into that data, like sales is a whole piece. Our whole sales team learned how to measure and kind of what we call measure up your funnel, meaning from brand new ideas all the way to closing someone as a customer. There's a number of ways to track your measurements and data on that too. So we can dive a little bit into that. And I'm going to use another example on the next company of how I did that. But any questions just off the bat around first ideas of KPIs or anyone using KPIs for anything that you're doing right now?
I think in Malaysia, generally, we are using KPI. I mean, in MMU, yeah.
Yeah.
The days where they want to check our KPIs are the days where we fear the most.
Yeah, I'm sure. Right? Yeah. All right. What's the criteria to be an astronaut? In the U.S., I only know the U.S. What in the States, what it is. Typically, you have to have a background in usually. So this isn't hard and fast only, but typically you're either a pilot of some sort. So you have to know how to fly a plane, and you have to have had a certain amount of thousands of hours flying multiple planes. So a lot of times for the pilot kind of roles, most people are coming from like the military, Air Force, Marines, and Navy pilots. On the researcher side, a lot of times you've studied a specific thing that you then are probably the top of your class at researching. So you probably have a PhD in maybe in engineering for how like certain materials come together and you're testing that in space, or maybe in biology and you're testing something on the space station that is biology related. But typically it is research based for a lot of the other astronauts that are up in the space station. They have specific reason to use this space as a laboratory. So yeah, you're typically a pilot or a researcher, PhD of some sort. There is a lot of just kind of general engineers when we were building the space station that were helping putting hardware together in space. And so you had to be, physically fit to be able to, be in pretty extreme environments, as well as understand mechanisms. So if something fails, like a solar panel, can you think on your feet, how could I fix this? You have to know really, really well what are all the options to fixing something in space. So those are, I would say, some of the backgrounds I see. I am not that physically fit, not anymore. I do like to run, and I used to run very long distances, but running doesn't help in space too much. You want to travel the moon or Mars for a week? We don't have any hardware that could take you there right now. I think Richard Branson is I think just in the next week is going to have he's going to go to space. So watch out for that. That should be interesting. But it's only going to go just outside the atmosphere. And I don't think SpaceX is open to tourists yet. I don't think you can buy your way up on a Falcon 9 yet. But I do think Blue Origin is going to get there first. So Jeff Bezos is going up to space in about a month, I think. But yeah, I think your best option is going to go through Virgin Galactic. I think it's a $250,000 ticket right now, maybe a little more. But it still doesn't really get you that high up. It definitely doesn't get you to the moon. So yeah, Song, you got a while to go till the technology catches up for us. Why is it once we land people on Mars, we can't bring them back, but we can retrieve a sample? So we actually haven't retrieved a sample from Mars yet. I don't think. Maybe we have once, but most of everything we've launched to Mars is still there. The big thing is it takes so long to get there. So it's the closest Mars gets, I think it takes 6 months. The furthest Mars gets, it takes 18 months, one direction to get there. So that's part of it, is one, it takes so long that we only have so much hardware we can take. We have to build things really, really small. And it's just so much easier right now to send it one way. If we had to bring it back, we either would have to build a whole new propulsion system that can lift off of Mars that we wouldn't use for quite a while, right? We would be there on Mars, we'd do the mission, and there'd be this whole engine not being used that we could have brought more material with us to do more tests on Mars. So right now, it's just not a cost-effective manner to have a round trip to Mars. I think once life is involved, then we will have to, right? We will have to design things that come back. Right now, if a rover breaks on Mars, like great, we don't, no loss of life. So right now it's just a kind of a cost and weight balance that we go through. I'm going to take you through a reason why I started my second startup. So Portfolium, we had really good success with selling universities, and we ultimately were bought by another, university software company. But my whole goal was to help people get employed, and Portfolium, we help people get the tools to say, hey, you now know how to get employed, but we didn't close the loop. And so I was passionate about working on a product that really got people jobs. And so I actually left Portfolium early. I had a little bit of a falling out with my co-founder because I said, I want to work on the jobs part. And he wanted to focus on just selling in universities. And so I left before we got acquired, a few years before. I still had equity in my company. So I was still successful. Down the road, I successfully got some money back, which was great. But at the time, we didn't know we were going to be acquired. So it was kind of a risk to leave something that was working. But I really just passionately believed I wanted to help people get jobs. And so I joined another startup that was already working on this. There were about 20 people. It was a company called Hired.com. And Hired.com is also a two-sided marketplace where it connects talent and companies. So what we did was, and when I joined, like I said, we were 20 people. Over 18 months, we eventually became 350 people. So we grew really, really fast. And I was a part of the team that launched new cities. So when I started, we were just in San Francisco and New York. We would acquire a bunch of people who were looking for jobs, and we were acquiring companies. And every Monday, we had kind of like almost like semi-like Tinder, more like Match.com. We would create matches. So we would say, all right, it's Monday. You're working at General Electric, or you're working at Coca-Cola, or sorry, companies. You're looking for these roles. All right, candidates, you have these kinds of skill sets. Our algorithms would match you on Monday and say, hey, you should meet. And the company would then say, hey, you look really interesting, candidate. Would you take an interview with us? And then we would get out of the way. So in a sense, we were kind of this matchmaking system that we were trying to build a smart algorithm that would match the right people, right? There's all these people who are interested in working and people who are trying to hire, but it's really hard to like find each other. We thought, let's be the matchmaker. And so I went to work on finding new cities to launch this site in. So I launched it in 12 other markets. I launched it in like Los Angeles and San Diego and Denver, but I also helped find the team launch it in Singapore. So Singapore was our first Asian city, and Australia as well too. We were live in Sydney and Melbourne. And so what it meant to be a launcher was that I had to, in a sense, do customer development in each of those cities and say, and kind of take this idea, this product that we already had, and see, does it work for you? Especially going to a new country like Singapore, we had to recheck ourselves on the revenue model. So would people pay for talent the same way they would back in the States? do interviews happen the same way? So even if someone meets someone, you know, does the same way that an interview happens, would that work on our site? So there's a lot of looking at both the same product, but also revenue model and sales to say an existing product, does this work scaling into other markets? And again, that was a data thing for me. I had to look at funnels. I had to look at from the point that someone signs up for the site to all the way that they get a job. Does that work in every new country that we were in? And we had a whole funnel. I wish I had a diagram to show it, but like we mapped the journey through our website from the moment you came to our website here to then you click get started to then started filling out. We knew every line, every time someone dropped off, we knew, you know, where that potential that would happen. We also knew the further along you got, obviously the higher chance you were to get a good job. We also knew that we had to re-engage people when they fell off at certain parts of our website, even just at sign up flow. You know, and I'm gonna like even like here, right? So first name, you can see we're very quickly trying to convert you. We don't want much information from you at all. Name, email, get started, because we know the quicker, the less fields you have, the more you will stay with us. So stuff like that, we all had to like get together with our product team, but also with our sales team and say, where are we losing people, and make sure that the data is flowing back and forth. And so that was a big factor in terms of building this out, especially when we had to localize and put this site in other languages. Like we went to France, we had to build it in France, and we actually ultimately bought a company that was doing something very similar because it was so hard for us to design the site in French. Some of that were things that we had to weigh. How do we go into a new market? Do we buy our way in, or do we start from scratch? And that was a lot of the data pieces that people like me, boots on the ground, had to figure out when I would launch a new market. Any questions here?
Yeah, we have one question. Chen Tong asked, want to ask that what's inspired you to become astronaut the most? Do you face any obstacle to become astronaut too? So you're going back to
Space, the final
yes.
frontier. I was not an astronaut. I never went to space. Honestly, I applied for a ton of jobs out of school, and this was the best one I got. I did not grow up as like dreaming to work on space, to be honest. What I did find though is that everyone I worked with did. Everyone dreamed of working on space. And what I learned was the kind of this value of passion. The things you work on matter. And I ultimately found I didn't want to work on defense related things. I didn't want to work on, you know, bombs and missiles. I wanted to work on things that had an impact, a positive impact on the world. And when I went to go work here on the Space Shuttle, I also found that people there's just such an enthusiasm of helping explore a place that not many people have been. Also testing the limits of engineering. You know, we were testing the limits of metals and stuff like that. It was incredibly inspiring to be around people who were so passionate about what they did. And so that kind of changed me around the things I wanted to work on in the future. I don't think I had that going into my first job at all. I applied everywhere, but slowly realized the things you work on, you know, you get fired up by that.
And we also have a question from Aslam. He asked, how did you decide which company to buy to help your business?
We use data. We asked, you know, where's that beam again? We asked to get companies to lift up their hood and show us what they're working on. So what that means is that they had to know their data really well, right? They had to have a dashboard that they could explain to us in a really succinct manner. And we had to have similar data, right? We had to have data that talked. If they were measuring completely different things, maybe it wasn't going to be a good fit. If you weren't even tracking your data, you probably weren't data centric like us, right? You probably didn't take data as seriously as we did. And so there probably wasn't going to be a good cultural fit in terms of what you prioritize as well too. So, you know, that's a big part of it. Step one is who opens up their hood and shows us what they have.
Okay, so far that's all we have.
Okay.
Oh, okay, we have one more.
We got some good space questions coming on. Guys, yes. I am not the space expert, but I will take cracks at them. If you keep doing it, I will keep talking space because I like space just like the next person too.
So,
Terraforming.
Yeah. Terraforming.
Terraforming is, for the not everyone who understands, terraforming is pretty much like making Mars habitable, right? It's making it, whether it is converting, the dirt to rocket fuel, or creating oxygenated, out of the dirt and soil, or exploding the atmosphere so that you actually capture carbon dioxide into the atmosphere. Like, this is terraforming, making the Mars habitable. Elon believes in that. He believes that we should be doing that to make make planets habitable. I don't know. I think that's humans imposing will on other things. Like, I'm not sure if that's our purpose in life, to do that. What's also interesting, in a lot of sci-fi movies, you don't see that that's how we conquered places. Like, we didn't terraform places. So, and not to say that sci-fi is our future, but it's kind of interesting when sci-fi actually comes to life, and you don't actually see a lot of people changing other planets to make it habitable for humans. So maybe we just need to go and find the right place that has oxygen that humans can live on. I don't know. Rocket engine or booster. All right, let me read this real quick. Mostly dealing with combustion type. I have come across a rocket startup called Arca. They use pressurized water to propel the rocket instead. Have you ever come across this type? Would really love to hear. So this is interesting, actually. What we were doing was creating water, actually. So we had liquid hydrogen, liquid oxygen. We exploded them at a really high temperature, and we expelled water vapor. So that's actually what the space shuttle is powered by water to a certain extent. Very similar format. Water sitting in a tank is really heavy. So that's why having hydrogen and oxygen separated at really cold temperatures in their gaseous form was much lighter than carrying a giant tank of water. Water in its liquid form is really, really heavy. And so you wouldn't really be able to, you'd have to build a giant rocket, and it just wouldn't be as efficient as having a tank full of water as compared to just creating water out of oxygen and hydrogen. So actually, that is what the space shuttle was fired on. Question from, all right, around the tech field.
Yeah.
Oh, big tech. Ooh, we're getting, all right. Can we break up big tech? This is, I don't think I'm qualified to answer this question, to be honest. But the idea that, Google and Facebook and Twitter are too powerful, maybe there's something there. I think we have found that social media is dangerous in the wrong hands and in overconsumption. But I think that can be said for everything. I think moderation is the key for everything in life. And when we overindulge, bad things happen. Now, the question is, should someone be in charge of telling us that? I don't know, like, should you have too much sugar? The same thing, right? You could overeat yourself on sugar or alcohol or all the bad things. But I don't know if we're stopping those companies from making you make the wrong decisions. So I don't know. I don't know where the right answer is there. Like, who's really in charge for overindulgence on the human level? But it's a good question. We're getting deep here, guys. I appreciate it.
Yeah. Okay, wow. All right. Leadership and management theory.
Ooh, leadership management theory. I don't know if you're calling a specific theory on it, but I think if you are a startup founder, if you haven't managed someone before, you are going to have a really tough time working on your first startup. Because as an entrepreneur, the goal actually is not for you to do the work. The goal is for you to hire the smartest people to do the work and you to get out of the way. So as a founder, especially if you're the CEO, you are a talent scout and you're an ideator. So what you're doing is you're taking ideas, you're validating them, you're taking the validated idea and saying, who's the best person to work and take this idea and either build a product or to sell it or to market it. And then you get out of the way as the CEO. What that means is you need to, one, know how to scout talent really, really well. You say, who is the best marketer for Portfolio? That's who I need to hire. And then you get out of the way. But you also you manage them, right? You give them the tools that they need to grow and take your idea to fruition. So, if you have some management experience already, you're already a leg up. And so I think if you can go get management and leadership experience at another job first, get paid to do it, you're at a much better stage than doing it all from scratch the first time through. And so that's what I took away from working on rockets also, was learning how to work on a team, cross-functional team, people with different backgrounds, but also different skill sets. I also learned how to lead people and how to motivate people and get people to join me on my efforts. And I got paid to do it, which was great. And then when I went to go start Portfolium, I didn't have to learn that at the same time that I was actually having to do it, which is really tough. If you're learning how to be a manager while managing people, it's tough, and you're gonna struggle more. And with startups, time is your biggest currency. See, you're trying to build something and catch up to someone else who's already doing it, right? If you're building a better rocket, well, you got to catch up to Elon Musk, and he's been at it for 20 years. How do you catch up to him? Well, you do things really efficiently. You cut corners, and you take time off of his development. It took him 20 years to catch up to him. You got to get there in 3 years. How are you going to do that? You're going to hire the best people, and you're going to give them the tools that make them the most successful. So management, leadership, that's what it's all about. Also hiring and being able to find talent to come, and recruiting them to come work for you. That's sales also. So no matter what role you're in, you're going to be doing selling to tell people to, hey, come work for me, or come buy my product, or come give me money. Also a huge piece that I would say. So management, leadership, talent recruitment, and sales. Biggest skill sets for a CEO, entrepreneur.
Okay. So how do you interview people, and what are the top 3 questions you will ask? Wow.
Ooh, you know what? Interviewing, there is no secret sauce to the 3 questions to ask there. What I like to do, and honestly, in an interview is kind of a show, just like a pitch for fundraising. You're kind of, the other person's on their best, they're on their best behavior. What I like to do is see people in their natural environment. So what I like to do is usually give people assignments and pay them. So I will hire people for a task. Say, hey, come do something with me. Let me see if we work together well. If you can do that, right? And so I look for part-time workers and contractors, and then I look to see, do they have long-term potential, and can we elevate them to full-time? Now, not every role can be hired like that, right? Sometimes there's tasks that just can't be part-time. But that is my ideal, is to, if in a perfect world, I love to see people actually do the work and work with them. And that's going to be the true test of, am I going to like working with them? And could I envision that hiring them? So I didn't give you your answer for the top 3 questions, but really the see through the kind of the polish, and look for people's actual true intent. That's what I have to look for.
Okay, I'm quite aware of the time, and we would like to hear, because we know that you are CEO of Rising Tide, and you are also with Fresh Brewed Tech and Fresh Squeezed. I would like to hear about that, and you are also managing director of Interlock Capital. So, what's your you want to know this your roles in these companies, and what do they do in these startups, and also what's your typical day-to-day like, because there's so many under your belt. Wow.
All right, I'll try to get through that quickly so that you can see, I can show you some of those stuff. So while I was building Portfolium, I got into an incubator. It was about 30 companies in the incubator. So physically, I was in a room with 30 other startups. And very quickly, we realized, wow, we all are going through something really unique right now, right? We're learning how to run a business. We're learning how to validate ideas. There's something to be said here about 30 companies in one space. And I got really inspired about building a space that inspired other people to be entrepreneurs. And so that is what ultimately became Startup San Diego. So let me share my screen again. Startup San Diego became a nonprofit that, I have it queued up, that is focused on inspiring entrepreneurship. So helping people kind of like take their ideas and say, what do I do with these ideas? Well, we have programs to help you ideate, and validate and do customer development. We also realized, like, in a startup community, there's a lot of organizations all trying to help the entrepreneur, but they may not be all helpful at the exact moment that the entrepreneur needs it. So an entrepreneur, when you're ideating, you're not really hiring 100 people, right? When you're thinking about how do I take this idea and turn it into a business, you're not raising $100 million in funding. So we wanted to help orient the ecosystem and say, okay, here's who helps you at ideation. Here's the other organizations that help you hire your first person. Here's other organizations that help you raise your first funding. And so Startup San Diego became kind of this organization of organizations that helped all the community find their way in where they are in their journey as an entrepreneur. So I got very passionate in that. Building this nonprofit, it became, now it's got a 3,000 person annual conference called San Diego Startup Week. We actually have a series of videos that might be good for all of you called the Startup Series. And it's 5 videos about how to get into the entrepreneurial mindset. So we've got a video on how to be a leader, how to embrace resiliency and finding opportunities, how to understand customer empathy. And so all these videos are on the website, and you can go and watch them now. And these are videos we recorded a year ago. And we realized, like, content's super important for people who are working on their idea in their garage and may not have other people with them. So check out startupsd.org and go to the Startup Series, and you'll find that content there. All of our events also right now are virtual, and so you actually could join if you have any reason to get to know our community here too. So anyway, I was building that while I was building Portfolio. This was kind of a volunteer thing that I did. I'm still on the board there, and I realized there's 2 other areas that our community was missing. One, we were missing notoriety, meaning no one knew San Diego was a startup community. And so we needed to kind of shout from the rooftops, hey, here's what we're doing. Here's the companies we're proud of. Here's the exits we've had. Here are the people that make up our space. And that didn't exist. And I started a blog called Fresh Brewed Tech that is all about sharing our love of San Diego tech and tacos, because tacos are a big part of our scene. And so Fresh Brewed Tech is a media company that I created 3 years ago. We have a blog, we have a podcast, we have an email newsletter, and we have a job board that help people get to know San Diego as a tech community. So not only startups, big tech too. And we write articles. We just had an event all about cybersecurity. And so Fresh Brewed Tech was my first kind of foray into building a media site. And I've now built one for Orange County called Fresh Squeeze Tech. We just launched Santa Barbara called Fresh Coast Tech. And so I'm kind of in this new market launch mentality where I've got a product, it's working in one community, and we're trying it out in other communities. And so I'm kind of like at hired.com again, I'm launching new cities. The piece that I'm struggling with right now is how to build a cohesive brand, because I've built 3 different brands: Fresh Brewed Tech, Fresh Squeeze Tech, Fresh Coast Tech. So I think I need to figure out how to connect all these, freshtech.com maybe. And there's these sub media sites for each city. But yeah, I'm kind of early in my journey right now. I'm building this new company. I've got a team of about 10 that help me. So it's not just me, luckily. So that's how I'm able to do a lot of the work during the day. But yeah, we're kind of building tech media sites to evangelize cities. And Rising Tide Partners is part of this. So Rising Tide Partners owns this site. It's kind of the actual company name. But the other piece that we weren't expecting to have happen was that city governments, or even state governments and county governments, they reached out and said, this site that you built, can you do a white labeled version for our city? And can you promote our city as a tech community? And so we now have 15 cities where we create content and promote the business and startup and tech community on behalf of a city. And so we've built another business out of this media site. And now we have clients. In a sense, it's a service-based business where we're helping create content. And I'll share what some of that content looks like on our own blog. We're, in a sense, we're helping build community. And so now, like, say, City of Vista, we write an article about their wine region. Or City of Carlsbad, here's what it's like to vacation there. Here's one about how zoning applications help the city of Escondido support new businesses to move to the area. So yeah, we're kind of writing content for cities to say, here's how businesses live and work within a city. So that's what Rising Tide Partners is. And that's how they go hand in hand with Fresh Brew Tech. Fresh Brew Tech is similar. It's just about, you know, the tech and ecosystem. And so I said I wanted to work on two things once so notoriety, from telling people about San Diego as a city. The other piece that I saw we were lacking is capital. We do not have still a lot of investment capital local to San Diego that would invest in San Diego companies. And so I built Interlock Capital with another partner. And actually Sunaik was at the meeting where we decided to, where my partner pitched me on this. Fast forward a year and we actually built it. And so this is a startup investment group where we recruit entrepreneurs and other smart people to join us and write small checks as little as $1,000. And we collectively pool our money and invest in startups. And so 1 year later, we have written 12 checks. We've invested in 12 companies for about 2.7 million in funding. One thing we're really proud of is trying to also on the data side, we want to make sure that we are holding ourselves accountable and we're investing in not just anyone, but we invest in a balance of our community. And so we have a dashboard that shows here's our investments, here's the time frame it takes between investments, and then what's the makeup of our companies. So we've it says 11 because one company we've invested in twice now. 55% of our companies have female leadership, and we are now kind of surveying our portfolio to understand the ethnicity diversity, so we can also say here's the makeup of our founders. We're doing the same on the 200 people who've written a check with us. We also want to start documenting what's the makeup of that, so from gender and ethnicity as well too. And so that's something we're working on now with Interlock Capital, is measuring and being transparent publicly of, are we investing in people that, you know, make up our community as well too. So that's Interlock. So Interlock is not a venture fund right now. We create an LLC, so a company for each investment. So we spin up an LLC and say, all right, we're going to invest in this company. We spin up the LLC, and so anyone can join into that LLC and invest in just that company. We want to raise a venture fund so that we can consistently write $250,000 checks into every company. And so that's what we're working on next, is raising a venture fund of probably $20 to $25 million in funding. And none of that would be possible if I didn't have just the background that I did. People are investing in me, really, to say, wow, you have built some things, you've been successful, we believe that you'll be successful next. And so very much like starting a startup, it's just like this. I have to sell my track record again to say, join me in investing in good people, because that's really what you're investing in. As an angel investor, as a venture fund, I'm investing in people. I'm not investing in ideas per se. I think any one of us could have thought of SpaceX. Only one person is the executor of that idea, right? And so I'm looking to invest in people. And to do that, I have to sell people, hey, trust me with your money. I will invest in other good people as well too. So yeah, selling is a great skill that will always come in handy throughout your life. That's for sure.
You know, when you said you created LLCs for each investment, does that mean that at the moment you have invested in 12 companies? Does that mean that you have 12 LLCs?
That is, yes, correct. Yep. So we are managing 12 LLCs. Each one has different amount of people who joined in as investors in that LLC. So you could see let's see, Cass came along and you're like, I don't want to do that deal. That's okay. You don't have to join us in that one. You can wait for Launch Factory, or you can wait for Forecaster. That's kind of the beauty of using what we call, it's called an angel syndicate, meaning it's deal by deal. People join in each deal or they pass, and that's totally okay too. Does that make sense?
But these startups, they come from your, because they invest, because they believe in you, because they believe in your ability to be able to pick out what will work and what will not work.
Yeah.
Right?
So let me explain the investment piece. So Cast is a C Corp. We as an LLC, right, give them a check. So we in a sense, instead of having 50 investors from CAST, they get one check from us. And so, yeah, people join us. Those 50 people that join in the CAST investment, they join, say, Interlock CAST LLC investment group, and we write one check to them. And yeah, and people believe that we found a good deal in CAST. It's good people, good idea, good traction. And so that's why people join us in Interlock Capital.
All right. Okay. Do we have any questions? Johan. So what entrepreneurship meant to you, and how do you navigate uncertainties? Wow. Okay. Let's say the problem are new and previous data doesn't exist. How would you decide what to do next?
That's a good question. Entrepreneurship to me is a fewfold. One, it's always a journey of learning about myself. It's a journey about learning about something new that I am curious about. And it's a journey of problem solving. So I take all three of those into account when I'm moving forward into something. For me, learning about myself means learning about what I'm good at and what I'm not, right? And so when I look at my skill sets and my strengths, and I'm looking at a problem in front of me, I want to look at who could join me on this that would fill in my gaps. What are the problems that we're going to solve that I'm not going to be good at solving? But if I bring someone with me, we are a power team. So entrepreneurship is looking at complementary skill sets to say, 1 + 1 = 3, right? If I am half the equation and a co-founder is the other half, together we should be able to solve anything. Or maybe it takes 3 of you or 4 of you. So part of that is right? Is putting talent into a crucible and saying, what talent do we have here? And all this talent, what problems could we solve? So that's one. I think entrepreneurship is super important around that. Also looking at risk taking, like you mentioned, right? So what do all of us have the same risk profile? And are we willing to take the same risks together? And so finding co-founders with that kind of alignment is super important. Are you focused on solving something that is going to take 10 years? Do all of you have the willpower to stay for 10 years if it takes that long? If we run out of money, what are we all going to do? So a lot about entrepreneurship is actually having some really important and deep conversations with someone else, other people, and making sure you're on the same page as them. Are we willing to get married, right? And if we don't, what does divorce look like, right? If we break up, are we okay with carving up the company or walking away? So a lot of that of entrepreneurship is those pieces are overlooked of how do you recruit complementary skill set people, so people who aren't just like you, who have risk profiles like you and have a time horizon like you. So all that, we haven't even addressed the idea or the problem yet, right? These are just qualities in someone else that do they fit, do they match? Now let's take into effect the effect of how do we solve a problem? And that's super important, right? Do some people run at it and say, I'm going to go right at trying to figure out how to solve this? Do other people take more of a research approach and say, how has this problem been solved before? Let's look at previous examples. Do others say, let's go right at our competitors and see how they're doing it? So all those are different ways to approach how do you solve a problem. You can also look at it in a technical way. Could we code our way out of it? Or should we not write a line of code, and should we try to manifest an idea and talk to people and say, hey, if this idea existed, would you buy it, before ever building a solution to it too? So all those are ways that you and a team are going to learn how to work together, right? How do you approach a problem and how do you solve it as well too? So I don't think that's the exact answer you're looking at, but those are some first ideas that come to mind around how do you approach team building the right team, and approaching a problem itself. And I want to be respectful of time, so I'm going to move on to the next questions. And if we have more, if you want to ask more, Johan, I'm happy to take more too.
That's a personal question. We don't know what yet.
Go for it. If you're willing to ask it in front of everyone else, I'm willing to answer.
Yeah, go ahead. Oh, okay. All right.
I'm gonna. I'm going to go to Song's other question as well too. Do you invest more in crypto or stock? As an investor, would you rather earn stable, low API, central bank, or investing in them? Do you see any future in cryptocurrency as an entrepreneur investor? Okay. Investment wise, I actually believe in a few things. One, investing not everything into one thing. So having a balanced portfolio. I invest in public stocks. I invest in private companies. I invest in crypto. I invest a little bit in real estate. And I put some money in savings, right? And so for me, investing, for me, I'm willing to, what I think investing for me is the ability to learn. Now it's kind of like school. School, you're paying to learn. When you're on a job, you're getting paid to learn. And investing, I'm now paying to learn again. And so for me, everything is about learning. I am willing to write checks to obtain some knowledge, whether it's about an industry or about myself, right? If I believe that, you know, Japan Airlines is going to go up in a year, I'm willing to learn and gut check myself. Did I really have conviction in that? Well, let's see in a year, you know, did the stock go up or down? So I take everything investment as learning, first of all. I'm only willing to put money into things I'm interested in learning in. So crypto is one of those areas I've been investing in for 4 or 5 years because I've been interested in it. I have been waiting to see true applications of crypto, of the currency side of crypto. I believe in Bitcoin because there's not much of it. So I think it's a scarce asset that everyone should have a little piece of because it's going to go up. But I haven't found its true application. Like, it's not rocket fuel. I can't put Bitcoin in my car and get me to Mars, right? So I'm still waiting to see. I have not like invested in a cryptocurrency company with other people's money yet because I haven't seen the right application for it yet. But I'm optimistic, and I think people should keep working on it, and it will emerge. But I just haven't put money there yet from someone else's money. I have plenty of Bitcoin and Ethereum, and I've been mining Ethereum personally because I've been interested and fascinated about learning it. Hopefully that answered your question. Vivian, how do you handle issues with conflict and disagreements between co-founders? That's such an important question. Me and my co-founder fell into this problem. What I think you should do is write out all the scenarios that you could disagree on things and hash out what could happen. In a sense, I talked about divorce. That's kind of what happened with me and my co-founder. We decided to split because I think we were too similar, actually. We were both engineers, both had the exact same skill sets. We were too homogenous. And we also lived together, by the way, too, which was also a little dangerous, I think, too, living and working together. It was just a little too much going on. And we didn't talk about what happens when we get into disagreements. How do we resolve conflict? And we should have talked about it. Like, hey, Adam, you don't like conflict. Maybe I don't either. Okay, if we know we're going to avoid conflict, let's talk about our personalities and say, how would we like to talk about conflict? Maybe we want to write it out instead of talk about it. Maybe we bring a third party in who helps us, coach us through a conversation together. But you absolutely, with your co-founder, you need to address and learn each other's habits, learn each other's abilities, so that when bad things happen, you have a framework to say, here's how we do it. So I'm not going to tell you necessarily how to do it, but make sure that you understand that you need a framework for addressing conflict, dissolution. When times are tough, how do you need to get motivated to keep working? All those things are things you should address before you really go into business with someone else. And I would say it's tough to know that. You got to learn a lot about yourself first. And if you don't know enough about yourself, it's tough for you to ever know about someone else too. And it's kind of like finding a partner that you date and marry. It's the same scenario, right? Like, if you don't know enough about yourself, you're not going to be able to be a good partner to someone else too. So, that's why they talk about startups being a marriage, because it really is. You have to learn a lot about each other, like a prenup, kind of. Yeah, like, it is important to actually have an exit plan. If you're not on the same page, if one person wants to get out in 2 years and you're like, I'm in for life, like, if you didn't know that about each other, in 2 years, you're going to find out, and it's going to be ugly. And so really being able to have real conversations with your co-founders is really, really important. So learning how to communicate, that's step one. And two, learning the differences of how you two communicate. is kind of the next piece there. Hopefully that's helpful.
Well, 11:59. Neil.
Yeah, I'm happy to take a few more if we need, but also want to be respectful of everyone's time too.
So do we have any more questions? So, go ask away. And you're also welcome to switch on your mic. Turn on your mic and then, just speak to Adam. Do it to Neil, sorry.
I'm going to give you a few spots that you can follow me. If you do want to follow up with me, on Twitter, I'm at Neal Bloom. Feel free, to follow me there. LinkedIn as well. Maybe some of you already found me on LinkedIn. If you do find me on LinkedIn, I will say, write me a little note that says how we got connected. Just say, hey, saw you at this panel, just so I have some context. And if you have an ask for me, even better, right? So I don't for any of us, if you just say connect, hard to know, are we valuable for each other's network? So yeah, just make sure when you connect with me on LinkedIn, let me know where you saw me and if there's something I can help you with. There's also some online communities that I'm involved in. So I don't know if any of you use Slack, but the San Diego community has a really popular Slack group. So feel free to join in and find me on Slack. If you use Slack, I'm very much, I will answer questions quicker on Slack than email. That's for sure. That's why I'm not giving you my email, because I am not great on email. Futri would know that also, how long it takes me to respond sometimes. So email is my least favorite mode of communication. Well, I hope this was helpful. I hope I inspire some of you to work on startups, to maybe go into space, maybe do both. And we got a few more questions still.
Yes, you got a few more coming.
When should you give up? Big one. Never. No, I'm just kidding. Look, your health and safety is number one most important thing. So make sure that, and I'm talking physical and mental health too. So make sure that you are always happy in what you're working on. I will say, look, within a given day, things are gonna be tough, right? Maybe even a given week could be a tough week or a tough month on your startup. But overall, if you are passionate about what you're working on, that is number one importance in terms of keeping you motivated. But don't do it at the expense of your safety and your health. So that's kind of a high level thing. But also, the passion is real. If you aren't passionate about the problem you're solving, it might be okay to walk away if you have talked about an exit plan with your co-founders, or if you have investors, you got to talk to them as well too. So those are all pieces where it might not be easy to just walk away. If it's just you and you can close up shop and you don't have employees and some of that, okay, maybe it might be easier. But the second you start hiring people and taking other people's money, you've got some responsibility to others, and you have to do the right thing, because you don't want to burn a bridge if you don't have to. If someone backed you now, and let's say the business didn't work, and you're honest with them and say, hey, we went about the problem solving it in the wrong way, or we spent the money in the wrong way. If you're honest, they'll say, hey, as long as you learn something, I might back you on the next one too. So I would say don't quit in ways that burn bridges. Do the right thing for yourself first, and then everyone who relies on you, employees, customers and clients, and your investors. But yeah, there's no line in the sand that says today's the day to quit. You just got to be able to look at your priorities and do the right thing. Sorry, don't have the silver bullet answer for you. I mean, and life is never really, there's no silver bullet answer for anything, right? Rasika, what did you major in college, and what skills achievements did you work on that helped you land such a great job? Great question. I studied mechanical engineering in college, and I applied. I first of all, I was a transfer student, so I started at a community college and then transferred to a public university. So I already felt like I was behind all my other classmates, because they had already, worked on campus and were in clubs. And so I quickly got into a bunch of clubs and thought, all right, I'm gonna get my job by being very active in clubs. Well, my internship and my full-time job, I got by applying online. It was not planned at all. It was kind of the luck of the draw. I applied to a whole bunch, volume play. I applied to 60, 70 jobs. And that is not how I've ever thought I would get a job. And every job since, well, I haven't really had a job since. Everything I've started on my own, but it's all been through my network. It's all been through who I knew. And so honestly, it wasn't about my mechanical engineering degree, because there was 100 or 200 other mechanical engineers who graduate the same degree. For me, it was what is the skill sets that I have that make me unique from all my other fellow classmates. For me, I started to learn that I could sell, I could tell a good story, or I think I can tell a good story, whereas most engineers couldn't. They're kind of shy, not good at communication and people skills. And so I thought, oh, great, that's something I can harp on. I can show and talk about my skill sets. And that's what I started to learn and harp on. And so I kind of said, yes, I have an engineering degree, but that's not what I focused on at all. It wasn't the degree. It was the other soft skills that were unique that my other fellow classmates, I felt like, weren't as strong in. So yeah, I'd say do similar things, like find the things that you're good at, and focus on that.